CE327L, Atterberg Limits Testing, an overview. The Atterberg limits are a measure of a soil's ability to absorb and hold water and are used to define plasticity of the soil. There are two Atterberg limits for engineering usage, the liquid limit and the plastic limit, each with its own standardized test. These tests are important in the classification of fine-grained soils. In particular, the liquid limit and plastic limit are used to distinguish silts from clays and to classify the plasticities of silts and clays. Atterberg limits tests quantify the relationship between the consistency of a soil and its moisture content. ASTM D4318 defines consistency as the relative ease with which a soil can be deformed. Thus, a soil with a soft consistency can easily be deformed and molded without cracking, while a soil with a stiff consistency cannot be deformed without cracking or breaking apart. Consider a sample of clay or silty soil that is relatively dry with a moisture content of, say, 10%. At this moisture content, the soil will be stiff and act as a semi-solid material that can be deformed but will crack if you try and mold it into different shapes. As water is added to this soil sample, increasing its moisture content, it will become progressively softer. At some point, it will no longer act as a semi-solid material, but will act as a plastic material that can be deformed and molded without cracking. If additional water is added, further increasing the moisture content of the soil will eventually act as a viscous liquid that will ooze and flow. The Atterberg limits are water content measurements that define the boundaries between the three soil states of semi-solid, plastic, and liquid. When a soil has a moisture content at its plastic limit, it is at the boundary between semi-solid and plastic behavior. If water is removed from the soil, it will behave like a semi-solid that cracks when it is deformed. If water is added, it will act like a plastic material that will be moldable and deform without cracking. When a soil has a moisture content at its liquid limit, it is at the boundary between plastic and liquid behavior. If water is removed, it will act like a plastic material that will be moldable and deform without cracking. If water is added, it will act like a viscous liquid that can ooze and flow. The purpose of the Atterberg limits test is to determine these moisture contents in a standardized way. For example, if the tests indicate the soil is at its liquid limit when it has a moisture content of 61%, then its liquid limit, LL, is 61. Likewise, if the tests determine that it is at its plastic limit when its moisture content is 22%, then the plastic limit, PL, is 22. There are two different tests, one to determine each of the Atterberg limits. Each test has its own equipment and procedures. But before discussing the equipment, we must first describe how to prepare samples for testing. You will need 150 to 300 grams of soil for these tests. These tests are performed on only the fine-grained portion of the soil. If the soil contains significant amounts of sand or gravel, we must pass the soil through a number 40 sieve to remove the larger sand and gravel particles before performing the Atterberg limits test. However, in sieving the soil, it is important that we don't remove silt and clay lumps with the sand particles. Therefore, sample preparation is needed. The soil must be dry enough that you can sieve it, but not so dry that you cannot break up the clay and silt lumps. Check the moisture content of the soil. If needed, dry the soil out by placing it in the sun or in the microwave oven until it can be pulverized by a mortar and pestle. Once the sample is properly dried, use a mortar and pestle to break up the silt and clay lumps until they can pass through the number 40 sieve. Use just enough force to break up the clay and silt lumps without breaking up the sand and gravel pieces. The objective is to separate the larger sand and gravel from the clay and silt. If the soil being tested contains little or no material coarser than a number 40 sieve, you can skip this pulverizing and sieving procedure. The plastic limit test procedure involves taking a sample of soil slightly wetter than the plastic limit and carefully rolling the soil sample into a thread 1/8 of an inch in diameter, as shown. So long as the soil can be rolled into a 1/8 inch diameter rod without falling apart, the soil is wetter than the plastic limit. As the soil is manipulated and rolled out, it gradually loses water. When it reaches the point where it crumbles or breaks apart as it is rolled into a 1/8 inch diameter rod, it is at the plastic limit. To perform the test, select a sample of soil about the size of a small marble. You should be able to roll the soil into a ball without it cracking, but it should not be sticky. Roll the ball of soil into a rod on the frosted side of the glass plate. Continue rolling it relatively quickly until it is 1/8 of an inch in diameter. Use the 1/8 inch diameter brass rod as a guide. Once you have made the 1/8 inch diameter thread, pick it up. If it remains intact, remold the sample into a ball and roll it out again. When the soil crumbles or breaks into pieces as you roll it out, it is at its plastic limit. When the soil reaches the plastic limit, put it into a pre-weighed sample tin and place the lid on the tin. Repeat this procedure with new balls of soil until you have accumulated 5 samples in the tin. Repeat the entire procedure over again so that you have 2 tins of soil at the plastic limit. Each tin should have 5 separate samples. Once you have acquired your samples at the plastic limit, determine the water content of the samples using the normal procedures for water content testing. The liquid limit test requires 2 special pieces of equipment: the liquid limit device and the grooving tool. Before you can conduct the liquid limit test, it is necessary to adjust and calibrate the equipment. First, check the grooving tool to ensure that it is clean and that the tip is not wider than 2.1 millimeters. While checking the grooving tool, note that the butt end of the tool has a calibrated tab that is 10 millimeters high and 13 millimeters wide. Next, check the liquid limit device. Inspect the device for cleanliness. Check for proper functionality, ensuring that the cup falls freely and does not bind. Verify that the fall height of the cup is 10 millimeters. To do this, raise the cup to its highest position, then slide the grooving tool under the cup with the calibration tab up. When the cup is at the proper fall height, you should be able to feel the calibration tab drag on the bottom of the cup, but you should not be able to see the cup rise. If you don't feel the tab dragging on the bottom of the cup is too high. If the tab pushes the cup up visibly, then the cup is too low. Adjust the fall height as needed. Place a portion of your soil in an evaporating dish. Slowly add water to the soil and mix it using a spatula. Continue until the soil has a consistency slightly stiffer than that of toothpaste. Place a small sample of the soil in the lower portion of the device cup, using the spatula as shown. Once the soil is smoothed out in the cup, cut a V-shaped groove in the soil using the grooving tool. The groove should extend from the back to the front of the cup. A clear brass line should be visible at the bottom of the groove, as shown. The cup is then repeatedly dropped by rotating the crank counterclockwise. Use a rate of approximately 2 drops per second. Count the number of drops required for the groove to close a distance of 13 millimeters. Use the calibration tab on the grooving device as a reference. Record the number of drops on your data sheet under First Try. Reform the soil sample in the bottom of the cup. Cut a new groove and repeat the test. Keep repeating the test until you have 2 consecutive tests where the blow counts differ by 3 blows or less. Circle the final blow count. This will be the correct blow count for the test. Do not average the blow counts. After the final repetition, obtain a sample from the center of the cup in the location where the groove closed. Place the sample in a pre-weighed sample tin and obtain its moisture content using the normal procedures. The soil is said to be at the liquid limit when exactly 25 drops are required to close the groove 13 millimeters. If more than 25 blows are required, the soil is drier than the liquid limit. If less than 25, it is wetter than the liquid limit. Depending on the number of blows required to close the groove, add or remove water from the soil to make it more or less stiff, and repeat the test. It is not necessary to hit exactly 25 blows to complete the test properly. The goal is to obtain 3 samples with blow counts between 15 and 35. 1 sample with a count between 15 and 25 blows, 1 between 20 and 30, and 1 between 25 and 35 blows. If the number of blows is less than 15 or greater than 35, then the soil is too wet or too dry. Do not record the data. Adjust the moisture content of the sample and try again. Plot your data on a semi-log plot with blow count on a logarithmic horizontal axis and moisture content on an arithmetic vertical axis. Connect the points with the best fit straight line. The moisture content that corresponds to the intersection of this line and the 25 blow count coordinate is the liquid limit. The plasticity index, PI, is the numerical difference between the liquid limit and the plastic limit. It is a measure of how much water a soil can absorb between its plastic and liquid states. In this example, the plasticity index is equal to 61 minus 22, or 39. From the Atterberg limit test results, you can determine the group symbol and group name using the Unified Soil Classification System. This concludes this presentation. Please note the password. You will need it to take your pre-lab quiz.